So to find the significant figures, let's take some examples. For example, 589 has 3 significant figures, and 5.89 also have 3 significant figures. If the 0 is in the middle, no problem. For example, 403 has also 3 significant figures. Now, if you have some zeros on the right, here remember that if it is a decimal number, the zeros count as significant numbers. For example, 90.00 has 4 significant figures. 90.0 is considered as 3 significant figures. 90 point without anything after the point has 2 significant figures. 90 without a point, ما في decimal, 1 significant figure. Okay, so the only problem on the right is when you don't have a decimal, the 0 on the right will not count as a significant figure. Now, if the 0 is on the left, like 0.2, the zeros to the left, they are not considered as significant figures as well. So 0.2 is 1 significant figure, 0.21, 2 significant figures, 0.021, 2 significant figures. Now, if I ask you to round 693, like problem 1, to 1 significant figure, so the zeros on the right are not considered, so you'll tell me 600. And if I ask you to give me, to round it to 2 significant figures, it will be like 690. Now, if I ask you, like in problem 2, to round to 2 significant figures, in part A, number 623, so you round down because 3 is less than 5, so of course you round down. If the number is greater than 5, you have to round up, so it will be 630, like in part B. 629 would be like 630. Now, if it is 5, you should decide whether it is you are rounding up or down. Actually, we need to find a way to make 50% of the numbers having 5 rounded up and 50% of these numbers rounded down. تنكون هيك عادلين to be fair with the 5. No, is it considered as greater than 5 or less? Actually, we are confused. So what you should know is you look at the digit before the 5. If it is even, you round down. If it is odd, you round up. Example 625, 2 اللي قدام ال 5 is even, so you round down. And if it is 635, you round up. هلا continue with the numbers لحديت from C to K بالexamples, and you will see that 50% of these numbers are rounded up and 50% are rounded down, so we are fair with the 5. Okay. Now, rounding is essential, like you will see in the slide, the next slide. It's essential for the calculation of error. So I need you to remember, for errors, you always have 1 significant figure. For example, x equals 2.83 blah 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 plus or minus 0.0791. Actually, you have to round it to 1 significant figure, so it will be 0.08. Now, since you have 2 digits past the decimal, you have to limit your value to the same precision. يعني 2.835 blah 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 should stop at 2.83, and you have to round this number. Since 51 is greater than 5, so you have to round it up, بتصير 2.84. هلا على graph, على axis, you can see that 2.84 is in the middle, and your value can belong to the interval between 2.76 اللي هي 2.84 minus 0.08, and the limit on the right will be 2.84 plus 0.08, which is 2.82. Okay, now if you want to make some measurements, it's whether you do them with an analog device or a digital device. The analog has some graduation. To find the uncertainty, you have to divide the smallest reading by 2. Now the smallest reading here is 1 degree. if you zoom into the figure, you can see that you have 1 degree in smaller graduations. So the smallest reading is 1 divided by 2, it will be 0.5 degrees. Now, the digital device has another definition for the uncertainty. It is the absolute value of the least significant digit. For example, 36.6, the least significant digit is 0.1. Of course, plus or minus. In this slide, you will learn how to calculate the average and the error on the average that we call alpha RMS. The average is very easy. For example, imagine you did the same experiment twice, and the first one gives you 16 and the second one gives you 18. Your average would be 17 because you add them and you divide by the number of trials, here too. Now imagine another student having the same average. For example, the first experiment gave him 14 and the other one 20. If you add them, divide by 2, you will get also 17. But you can feel that the first experiment is more accurate or more precise. Now, we will prove it by what we call the standard deviation, which means the distribution of these values with respect to the average. يعني إذا هود numbers are close enough to the average ولا لا. Okay? So this sigma أو standard deviation هي sum of di squared. di remember هي قديش بعيد ال value from the average x bar يعني the difference between them xi minus x bar divided by radical n minus 1. والفورمولا of the standard deviation والalpha RMS are very similar. الفرق بيناتهم هو divide by radical n. يعني في n بالdenominator وبقلب الراديكال that appears in the error. So if you already have the standard deviation, you need also to divide it by radical n, and thus you'll get the alpha RMS. Okay? Now let's prove that sigma x is smaller than sigma y. Actually, you have to substitute the values in the formula. So you have to add each value how far it is from the average, and you square it, you add them in the numerator, and then you divide it by radical n minus 1. Once you do it, you can see that the distribution is in x is narrower than the distribution for y. And remember to find the alpha RMS divided by radical n. You will get x bar, the average 17 plus or minus 1 for x, and y bar 17 but plus or minus 3 this time because the error is 3. You can do it with a calculator. I will teach you how to use a calculator to find these values يعني average, standard deviation والerror, and Excel is very quick, so please pay attention to the 2 following slides for this purpose. Here we have 2 experiments. The first one is done with an analog device and the second one with a digital device, and you can see that the digital device is more precise. Now, the 4 trials were made and we have to calculate the average on each one using Excel. So you have to click on the cell and write equal to start any formula. The formula is average, and you select after you open the parentheses all the data. You press enter. To find the standard deviation, the formula is STDEV. Again, you select your data. Now the error, unfortunately, there is no direct formula, so you have to take the STDV, you click on it, divided by radical n, square root of n. We have 4 trials, so 4, enter. Now the error has one, you have to round it to one significant figure, so you have to remove, oops, the other direction. Okay, so it's 0.4. This means that you have to stop at 1 decimal place after the dot. So here also you have to remove the zeros until you have 1 decimal place. the opposite direction. Perfect. So your final answer will be 38.0 plus or minus. I will add the symbol plus or minus. Okay, 0.4. Again, to repeat the same formulas, you don't have to write them down. You just need to drag to the right, and you will get, assume here you have more decimal places, like this, and here also. Okay, perfect. Now, let's see how we have to round it. As always, the error should be having one significant figure, so it's 0.05, rounding up. So here we have to stop at the digit 8, so we have to round down, so 38.68. The final answer will be, yes, plus or minus. I will copy the symbol plus or minus 0.05. Now, if you have the Casio calculator, please follow these steps. If not, please read the catalog of the calculator. Press on mode, then 3 stat, the mode statistics, then choose the one variable, plug in your variables. For example, in the table here, you have the temperature for the analog device 38, 39, 37, 38. So plug in these 4 values. Then press AC, and don't be afraid to press AC. It will not clear your data. Then press Shift, then 1. Choose 4 variable, and then you can whether choose 2 for the average or 4 as X for standard deviation. Unfortunately, there's no direct button for the error. So whenever you choose 4, you still have to divide it by radical of the number of trials. In this problem 4, divided by radical 4, and you will get your error. So you have three things to find: average, standard deviation, and error. هلا in the calculator you will see sigma x هي number 3 وال4 هي as x. Please choose ال4 and repeat it as هيك an exercise للdigital device. You will find these values. Remember that the error has one significant figure. So if the error has many digits after the dot, please round it up or down, it depends. And then limit your average to the decimal of the error to have the same decimal precision of the error. يعني مثلا بالانالوج you have one decimal place after هيدا so you put 38.0 whether for the digital device you have 2 decimal places, so you have to stop at 38.68. Now if you want to represent A versus M, A on the y-axis and M on the x-axis, of course you will have a hyperbola, for example, and in here it will not be linear, so it will be harder to study. To study it, maybe it's better to put on the x-axis 1 over m. This way, the mathematical formula would be y equal f, which is the slope, times x. الx هي ال 1 over m on the x-axis. So you just need to calculate the 1 over m. Each time you change the mass, your acceleration would be different, for example. And in this case, you can represent y versus 1 over m as a linear function where f would be the slope. Okay, this is an example. So any formula can be transformed into a linear formula, okay? For now, you are studying y, a variable, depending on an independent variable x. شو معناتها؟ يعني أنتوا you are changing x, a parameter in physics, and you will see its effect on another parameter y. You are not repeating the same experiment many times مثل قبل to find the average. No. You are changing your conditions and each time you find a new value y. الdistribution of points هن dotted points اللي على الجراف. These are your experimental answers. For each x عندك ال y and you measure them. هلا they are not perfectly linear بس فيكم تلاقوا شيء اسمه trend line using Excel for example or using the calculator. I will teach you how in a bit, but you know a line, the function is y equal bx plus a. Usually it is ax plus b من نحن وبالبروفي كانوا يقولوا لنا ax plus b, but in the calculator it is noted bx plus a. Whatever the notation is, whatever is in front of x راح يكون هو السلوب. In this problem ال bx يعني ال b هي السلوب. Okay? والA هي بسموها الy intercept يعني ال value where the trend line will touch the y axis. هلا EI is defined by the deviation يعني y minus yi يعني y تبع your point اللي هو الاكسبيرمنتال حنسميها نحن yi قد بعيدة عن y تبع الترند لاين. على الجراف you can see it, I call it EI, I call it error. اوكي هيك in gray. actually بتشبه الدي اي اللي عملناها قبل للافريج بس قبل كانت x minus x بار. هون ما في x بار ما في average. في كل بوينت قد بعيد عن الترند لاين، كل بوينت قد بعيد عن الترند لاين، واكيد كل ما نقرب على الترند لاين كل ما يكون احسن to minimize the errors. Now of course the error on the slope من experiment 5 وطلوع I would ask you to calculate the error on the slope. Let's explain it now, but you will not need it for the first 5 experiments. هلا هي it's a big formula, but actually it's very easy to find if you understand every parameter in it. So the error on the slope b squared equal n هي number of trials. يعني مثلا if you count هون how many points I have 1 2 3 4 5 6 7 8 9 so هي ال n هي 9 9 over n minus 2 بتصير 7 sum of ei squared. يعني انتم بتكونوا already الكالكوليتر عطتكم ال b وال a so you have ال y وال yi هي من ال experimental value so you can find ei easily. هيك بتربوهم بتيبل over delta. هلا الدلتا شوي غليظة كمان من التيبل you have الاكسس انتم تبعونكم الاكس of each trial so you have to add sum of xi squared تضربوها ب n هيدا أول ترم بقلب الدلتا minus انتبهوا هون ما في n يعني ال n هي بس لأول بارامتر minus sum of xi كليتها squared يعني you add ال xi and then you square them. okay على كل حال بتفهموها أكتر in an example. It's very easy, you will understand it later in an example. Assume you have two variables, y is dependent on x and you need to draw the graph. So you insert a graph and directly you can find the trend line or the linear, the regression line. So you double click and you add the trend line over here, and for more options you can display the equation on the chart and display the r squared on the chart. So this is easy, and as you can see it's perfectly linear. The equation is 5x plus 1. okay now if you go for the experimental part you repeat that same thing, you will find that the equation is very near to the theoretical one. Assume I will go back to the theoretical part. Remember 5 is the slope and y and 1 is the y-intercept. This means the line here is intersecting the y-axis at 1 not at 0. okay now let's go back over here. This one is like 4.9882x plus 0.2682 whatever. Now to find the slope and the error on the slope you have to apply this table. I will unhide it for you. You have to follow this exact order. xi you have xi squared, and for y you take the equation of the trend line you found 4.988, look at it here, and you multiply it by a2 the x. okay a2 is x, and then plus y-intercept 0.2682. And then you have to compare the trend line and the experimental values. To find the difference, you have to subtract them, okay? I don't care if it's negative or not because you will square it later on. These numbers are needed, and in blue you have to put the sum for each. For example, this one is the sum of all xi, and this one, it is the sum then squared. So the sum then squared, because it's hidden inside delta, you will need it. You will need this sum. This one over here is the second term in delta. N times sum of xi squared. So you add all the xi squared, okay, and then you multiply it by n. Here it's 11, because from 0 to 10 we have 11 trials. So 11 times 385 minus 3025, and you will get delta equals to 25.3. Actually, delta is needed to find the error on the slope, because if you go back over here, the error on the slope formula you have in the denominator delta, and ei squared is over here. So you have it. The sum is 2.55. Okay, so you have the numerator and denominator, and n, remember, it's 11. So you can find the error on the slope squared. EI on the graph is the error. So it is the distance between the trend line and each actual value, experimental value. Now you can find your Bx plus A and the regression R using Excel or the calculator. Now for the calculator, please follow these steps, and the R has a certain meaning. The more R is closer to 1, the more your regression line is perfect, okay? Or your distribution of points is more linear. In general, R squared هي رقم قريب ل 0.9. You will find it experimentally. إذا it's closer to 0, this means, أو إذا it is equal to 0 R, this means that X and Y are independent، يعني ما خصهم ببعض. And إذا كانت R مثلا 0.2، يعني 20% relation between X and Y، يعني correlation between X and Y is 20%. Assume you have, for example, a force sensor and you have measured the force F. وعندكم بعرفني balance, and you have measured the mass M. And you are asked to find the acceleration. Okay, very easy. You can calculate it. It's not measured, it is calculated. In this case, if I ask you to find the error on the acceleration, since A was calculated, not measured, you have to apply the formula of the propagation of error. اوكي، هي in purple او in pink اللي تحت. الerror on A for example، هيدا example، هي ال partial derivative of A with respect to F times the error of the force F كليتها squared plus the partial derivative of the acceleration with respect to the mass times the error of the mass كمان كليتها squared، وما تنسوا تحطوا الراديكال الكبيرة. هيدي هي الفورمولا. I can generalize it, okay, later on in another slide, to understand what the propagation of error is. So it helps me to find the error on a calculated value, okay, or quantity. Let's take an example. Assume your force is 9 newtons plus or minus 1 newton الerror. والماس هي 0.504 كيلوغرام، تقريبا نص كيلو، plus or minus البريسيجن أو الerror على الميجرمنت هي 0.001 كيلوغرام. كيف بعمل partial derivative؟ يعني إذا قالوا لي partial derivative with respect to F، بتطلع على الفورمولا ال A equal F over M، وبتخيل إنه بس ال F هي variable والM بعطيها رقم، يعني تخيلوها 3، كأنه عندكم F over 3. يعني شو الديريفاتيف تبعها؟ اوكي، هي 1 over 3، لأنه ال F عندها power 1، so وقت بتعملوا لها derivative بتصير 1 لل F. والM it's a number, it's not a variable، لأنه أنتوا عم تعملوا شيء اسمه partial derivative. Please اللي ما بيعرف partial derivative please review الكالكولس course. Anyway بتطلع 1 over M والماس هي 0.504. you substitute. Now partial derivative with respect to M Imagine that الm هي ال variable والf is a constant. So بعمل derivative with respect to n. شو الديريفاتيف تبع ال 1 over m؟ هي minus 1 over m squared times ال f بعملها كأنها constant. ال f بدلها f. And you substitute by their values. Now let's generalize this formula to a variable f depending on three measured quantities x, y, z. Each quantity مثلا let's imagine ان ال x هي mass وعندها a certain error when you measure the mass بيقولوا لك 0.504 kilogram plus or minus 0.001. هيدي 0.001 هي الألفا x هي ال error on the measured x. نفس الشيء لل y ولل z. So اللي بدكم تعملوه to find the error on f the calculated variable you have to derive your f partially with respect to x with respect to y with respect to z. You substitute the values you plug in the formula وما تخافوا إذا في شيء negative لأنه السكويرد يعني مثل قبل بين عندي minus 1 over m squared. ما تخافوا لأنه هيدي السكويرد اللي هون بقلب بطنة للراديكال will protect you from any minus لأنه تحت الراديكال ممنوع يكون في negative. Don't be afraid السكوير تبع الفورمولا is very easy for you. You need it actually. Second remark for you, please remember to round your error to one significant figure. يعني أنا الerror on f اعتبره طلعت معي 0.52. Remember to put it 0.5. وتالت شغلة بدي إياكم تنتبهوا لها وبليز تذكروها. كل شيء لازم يكون SI unit لأنه في أشياء ما بتزبط إذا ما كانت SI unit. So دايما تذكروا to put your quantities and to pay attention to the units. To put the quantities in SI unit. Okay, this slide is very, very important because each time we ask you to comment or to evaluate or to discuss your result. Okay, فهمنا عرفتوا تجيبوا كل ال values وعرفتوا how to calculate the error بس you have to discuss it. Each time I ask you that, please remember to calculate the percentage error to say if the experiment is accurate or not, and to calculate the relative error to say if the experiment is precise or not. هلا, let's start with the percentage error and discuss accuracy. ال percentage error by definition هي قديش الفرق بين الميجرمنت اللي هي experimental و theoretical. الفرق بيناتهم وقت بنحط absolute يعني we don't care مين minus مين، المهم يطلع الفاينل answer positive. ما تخافوا من الابسوليوت. divided by theoretical لأنه you have to find it with respect to the theoretical value. هلا قصة ال 100% يعني مثلا اعتبروا انتم الفراكشن طلعت 0.2 this means 20%. لو طلعت الفراكشن 0.02 يعني 2%. You always have to multiply it by 100% تيطلع لكم final answer. If your result أو هيدا percentage error طلع less than 10% you can say that it is accurate. If it is greater than 10% it's not accurate. Now to discuss the precision يعني انتو الديفايس تبعكم هل كان دقيق ولا لا هو عم بيقيس قبل البرسنتج ايرور اذا صبنا الهدف ولا لا. اوكي اذا صبنا الثيوريتيكال فاليو ولا لا. بس هلا بالبريسيجن بدنا نعمل شيء اسمه ريلاتيف ايرور. ما انتم كل ميجرمنت عندها ايرور لها بدكم تشوفوا العلاقه بيناتهم الايرور اند ذا ميجرمنت. You divide them دائما to compare two numbers we divide them. اوكي اذا طلع الرقم decimal كمان اصغر من 2% مثل ما قلنا قبل بتكون precise. أكبر من 2% بتكون not precise. Okay, and then when we say discuss or evaluate or comment غير إنه لازم تجيبوا accuracy وال precision you have also to give 3 sources of errors. Okay, without me telling you please each time we ask you to comment, evaluate or discuss please find accuracy with precision and then give 3 sources of errors. Assume we are doing the same experiment with 4 students and each student has a device. It can be less or more precise. هلا مبين مثلا ال part A is very precise، البريسيجن على C أداء بيرجع على A وبيرجع على B and D. اوكي ليش؟ لأنه الأرر تبعهم يعني هو الديفايس اللي عم يشتغلوا فيه بيكون دقيق أو لا. So the theoretical value هي 9.5. هلا مين أكتر شيء مبين قريب عن 9.5؟ مثلا ال لأنه كتير قريبة 9.61. So it is the more accurate من دون calculation we are just discussing. والمور البست precision هي عند السي N يعني. اوكي هلا let's do it by calculation. بالبارت A you apply the formula وبتطلعوا هو ده بيطلع لكم دايما decimal من الفراكشن you multiply it by 100% to find the percentage. So بدي اياكم تكونوا قوية بقصة الديسيمال وكيف how to convert it to percentage. إذا طلعت less than 10% فينا نقول إنه accurate. والبريسيجن بدكم تاخدوا الerror for each، يعني مثلا الerror بأول part هي 0.05 divide by the value اللي هي 9.61 بيطلع لكم 0.005 يعني it is 0.5%. less than 2% so it is precise. So أول تلميذ is accurate and precise. تاني تلميذ part B بدكم تشوفوا قديش ال 9 سنتيمتر بعيدة عن ال 9.5 with respect to the 9.5، يعني بتشوفوا الديفرنس بيناتهم divide by 9.5 بيطلع decimal 0.053 multiplied by 100% يعني 5.3%. less than 10% يعني it is accurate but unfortunately it's not precise. ليه؟ لأنه if you divide the error 2 centimeters على ال value 9 centimeters it will be 0.22. you multiply it by 100% it is 22.2%. so it's not precise and so on. Please do C with D انتو لحالكم and see and discuss if it is accurate or not, precise or not.